Okay, so in this problem we're going to try to find the Ksp of solid silver phosphate, and we're given the initial concentration, the equilibrium concentration of the silver ion is 1.28 times 10 to the negative fourth molar. So the first thing we need to do is we need to write out the reaction that's happening here. Silver phosphate, okay, silver is a charge of +1, so Ag, and phosphate is 3-, so we have Ag3PO4. Okay, and that's solid, and it is going to be at equilibrium with dissolving as silver ion, 3Ag+, plus the phosphate ion, PO4, 3-. Alright, so there's the reaction that we're looking at, and now what we need to do is simply create a Rice chart. The initial for the Ag3PO4 solid, of course, doesn't really matter because this is a pure solid, so its concentration isn't going to change at all. Initially, we'll say we added the solid, so we have no ions at all. Over time, that's obviously going to make plus 3x for the silver ion and plus x for the phosphate ion as they dissolve. Therefore, at equilibrium, silver will be 3x and phosphate will be x. Okay, the next thing we need to look at, as with most equilibrium problems, is the K. In this case, it's a Ksp. It's going to be the concentration of Ag plus cubed times the concentration of phosphate, PO4, 3-. Okay, so as we can see from this, therefore, our Ksp is going to be equal to 3x cubed times the phosphate, which is just x at equilibrium. Okay, so now what I'm given to work with is the initial concentration of the silver ion. Well, if I look, not the initial, sorry, I keep saying that, the concentration of the silver ion. If we look right here, 3x, my horrible handwriting scrawl right now, is going to be equal to 1.28 times 10 to the negative fourth. So we could simply say that concentration of silver ion is 1.28 times 10 to the negative fourth molar. That's equal to 3x, and therefore x is equal to 4.26 times 10 to the negative fifth molar. And that, therefore, is going to be equal to my phosphate. So now all I have to do is, well, there's two ways I could do it. I could simply say, plug this in for silver, 1.28 times 10 to the negative fourth, cube it, and multiply it by the concentration of the phosphate, which is 4.26 times 10 to the negative fifth. Or you could simply say that the Ksp is equal to 3 times 4.26 times 10 to the negative fifth cubed times 4.26 times 10 to the negative fifth, and get it that way. Either way you do it, the Ksp, I'll write it out doing it the silver way, is going to be equal to 1.28 times 10 to the negative fourth, and that'll be cubed times 4.26 times 10 to the negative fifth. Okay, and what it comes out to be is 8.93 times 10 to the negative 17th. Slightly different than the book value, at least the book value I used to write this problem, which is 8.89 times 10 to the negative 17th off a table when I created it. But again, if you're within a couple, because even a small change when you're raising things essentially to the fourth power makes a big difference. If we'd carried one more sig fig out, we would have gotten the right value, but then we would have also had another sig fig, and we didn't have that to go by on the table. So this is how you use a concentration to find the Ksp. And keep in mind that this concentration, we were just given it as concentration of Ag+, but you can imagine if it was a hydroxide, you could be given a pH. We could give you a certain number of grams of it that we dissolved into the water. And so there are lots of different ways to figure this type of problem out.